All right, game designers, let's talk about materials. My personal favorite part of just 3D modeling and set dressing in Unity. It's really satisfying to do, but it involves quite a bit of detail that we need to go over. So this video is going to be a little bit on the longer side, but let's go ahead and just jump right into it. I don't want to waste any time. So you can see in my scene here, I just have this very simple rock model that I've made in Maya, and I brought it into Unity. I imported the model in, and you can see it also came with the material that was made in Maya, but we're going to ignore that for now because I have my own set of textures here that we're going to use to create a material. So all these images here are called texture maps. Now, the reason why we are using maps is because we are doing something called PBR rendering. We're creating PBR materials, which means it's physically based rendering. And essentially what that means is that we are simulating surfaces using light. So these texture maps are giving us the data that we need to simulate these surfaces using light. Okay, so before we dive into making a material in Unity, let's go over what these different texture maps are and what they do. And I'm going to provide you a link to this little guide here as well that you can reference whenever you want. So we're going to start off with the color map. This also has multiple different names. Color map, base map, albedo, or diffuse. Different softwares use different names for this particular texture map. In Unity, it uses the word base map. But essentially all this is the color data for our texture. This is giving us, information about how the light, what light is being absorbed, by this material, what light is being, bounced back, all that kind of stuff. So this is our color map, just giving us the color data. And then we have something called a normal map. Now this is really interesting because what a normal map does is it simulates the bumps and hard edges of a material. Now it doesn't do this by actually physically changing the 3D model itself. It is using this color data that it has to simulate that depth. What it's doing is it is telling Unity, okay, these are the bumpy areas, this is how light should, interact with this surface, these are where shadows should be cast based on this color data, based on the bumpiness of what this material would be. So you can see in this example here, as it's starting to, come into shape, we are seeing the bumps of this surface come to life. Now remember, it is not changing the geometry of this sphere in any way whatsoever. This is all simulated. Now, that brings us to the next map, which is called a displacement map. This, on the other hand, actually does physically change the 3D model to get its effect. And you can even see the difference. You can see how some of the faces are extruding outwards and some of the faces are receding inwards on this 3D model here. And it's very noticeable when you do a side-by-side between the normal map and the displacement map. Displacement can also be called a height map. Now, both of these can be used in a game design environment, but for the materials that we're going to be making, we're going to be focusing on normal maps. Next we have reflection maps or specularity maps, and this is just essentially just tells the software, whatever software that you're using, how reflective a surface is. Next, we move on to a gloss or roughness map. There's a gloss map or roughness map. Now, this is where we're kind of going to get into the weeds here, but I'm going to describe this in the most straightforward way possible. So majority, or I should say at least the render pipelines in 3D modeling software, they use roughness maps to simulate how rough or smooth a particular surface is. The more smooth a surface is, the more reflective it is. The rougher a surface is, the less reflective it is. Now, in Maya, for example, we use roughness maps. In Unity, on the other hand, they use gloss maps. And essentially what that means is they are the opposite of one another. So a higher value in roughness means a surface is more rough. A higher value in glossiness means a surface is more glossy. They're the inverse of each other. And these are just used for different render pipelines. We are going to stick with using roughness maps because that is just the more widely accessible form of that type of texture map. You'll have an easier time finding roughness maps than gloss maps. So I'm going to show you how to use roughness maps inside of Unity. Next we have metalness, and this just simply dictates how metal or non-metal a surface is. We may potentially use these, but I don't think so. Ambient occlusion is a wonderful map that we may get around to using. We're only really going to be focusing on our base, our roughness, and our normal for the most part. But essentially, ambient occlusion simulates the self-shadowing of surfaces. So like the little corners on our bricks here, how they're creating shadows and things like that. It adds a really wonderful, nice little level of detail. And then masks speak for themselves. Essentially, it just simulates, empty space in a particular model. So black means it is not rendered, white means it's rendered. So you can see here, we can see through the black areas on this map, and we can't see through the white areas. We are not going to use any mask maps for this, but it's just good to know what they are. And then emission, we've gone over emission already in our other video. So this is an extensive list of all these different types of texture maps and what they do. You will have this link so that you can use it, but again, we are just going to be sticking to color, normal, and roughness for the majority of this. So still definitely take the time to understand what each of these materials do, but you will have a very strong understanding of at least roughness, normal, and color. So let's dive into actually making one of these. And I'm also going to give you a resource on where you can find these PBR texture maps as well. Okay, so back in Unity, I have my little rock model here. And let's go ahead and make a material using our color map, normal map, and roughness map. So I'm just going to right click in here, create, and I'm going to create a new material, and we are just going to call this new rock. Perfect. So in our inspector, we have some settings right out the gate. We have a workflow mode called metallic, and we can switch between metallic and specular, but for right now we're just going to leave it on metallic. Keep all of these default. In fact, I'm just going to go ahead and reset this just to make sure. Yep. So metallic, opaque, front, all this is staying exactly the same. And we are going to create this texture using Unity's default shader, which is Universal Render Pipeline, which is the renderer that we're using, and the shader is lit. So this is the one that is enabled by default. We are eventually going to change this so we can use our roughness maps appropriately, but for right now we are just going to take this, use the default to create our first material. So we have our rock here, which I'm going to go ahead and apply to this rock. Make sure I have it applied. New rock, yep, perfect. So let's go back to the inspector, and as we apply these materials, we are going to see this rock update in real time. So let's start with the color. I'm going to bring our base map, or color map, and just click and drag it right onto where the base map goes. and we can see that that color data has now been added to the rock. All right. Now there's another way that you can add these textures, and that's by clicking this little circle here, and that will open up our assets folder, and we can scroll through and look for our textures that we want. So that's another way to add it. I just like to click and drag it. So metallic map, we are going to go ahead and bring the roughness map on there for metalness. Now you can see that it's not really working the way you would expect. So a roughness map is supposed to simulate how rough a particular surface is, and a rock isn't metallic, isn't shiny like this, or at least most rocks aren't. We want a very rough rock. So the reason why this is behaving this way is because a metallic map or a gloss map is the opposite of what a roughness map is. So if this was set up properly, this would be a much darker color to represent that something is not very glossy. Fortunately, we can change this by using this smoothness slider here. I'm going to slide this all the way down. Now, but you're going to notice that we get kind of these weird foggy kind of reflections off of this material here. There, and that just kind of looks a little strange. We don't want that. And I'm going to show you how to fix that in just a bit, but let's continue on first. So I'm going to bring this normal map to simulate bumps into our normal map section right here. And now you can see how the light is bouncing off much more intricately off of our rock here. Let me go ahead and reapply that just so you can see the difference. I'm going to zoom in a little bit more. So here's our rock without the normal map. I'm going to go ahead and apply it. And now you can see how the light is just really bouncing off all the bumps of this rock. Now the first time that you bring in a normal map, and we'll go over this when we do a new one from scratch, we have to tell Unity that this is in fact a normal map, which we'll get to in just a bit. And we can also control how intense this simulation of bumps are using this normal map. I can crank this up to 2, and you can see as I continue to increase this, it is just getting more and more drastic and over-exaggerated with each increase. I'm just going to leave that at 1 for now because that looks good. So that is all we're really worrying about right now for our materials, or these 3 main texture maps: color, normal, and roughness. Obviously here you can see that we have slots for other maps if you want to use them. There's one for a height map. Again, that is physically actually changing the geometry of the shape. And we have the ambient occlusion map for those self shadows, but we're not going to worry about those right now. So let's start discussing, how we can fix this, strange reflections that we're getting off of our rock material here. Because Unity uses a metallic workflow, we need to change this to a workflow that is used by our 3D modeling software like Maya. So let's go ahead and do that. So under the shader in the inspector, I'm going to click on this drop down, and we're going to select a different shader. I'm going to go down to Universal Render Pipeline, which is the render pipeline we're using, and I want to select Autodesk Interactive. Autodesk is the company that owns the 3D modeling software called Maya. So I'm going to go to Autodesk Interactive and select Autodesk Interactive. We're not going to do masked or transparent, just this. Now, obviously, that is going to completely, reset this to a new material using this new pipeline, or this new shader, I should say. And by default, it has all of the maps disabled. They're still there, but they're disabled. So let me go ahead and enable these, but first what I'm going to do, under the metallic map, I'm going to go ahead and just select it and hit delete to get rid of that, and I'm going to apply our roughness map to the roughness map section right here. And then I'll go up and I'll just enable each of these individual texture maps and the roughness map right there. And there we go. Now our rock is behaving properly. It's not getting those really strange, weird reflections bouncing off using the lit universal render pipeline. because that is using a metallic workflow. We are using a roughness workflow. So that is all it takes to create a really good looking physically based rendered material. Again, this is using light, or we're simulating surfaces using light. That is all that is happening here. So with the absence of light, we are not able to do this, but because we have a nice directional light shining on here, we're able to create these really awesome photorealistic looking materials. Now, one thing that needs to be mentioned is when we are applying materials to these kinds of objects, it's very possible that you're going to see these kinds of seams present in each of these objects. That is normal. That is because when you have a 3D modeled object, you have to UV this object. And if we take a look at some 3D modeling software, and I were to look at the UV map of this rock, you do not know how to do this, but this is just for your own edification. It's important to know what the process of UVing is. This right here is a poorly optimized UV map of our rock right here. It's just one I made really quickly. But the process of UVing something means that we are making a cut somewhere on the edges of the geometry, and we are unfolding this object flat on a surface. A really great way to imagine this is using a cube as reference. So each face of the cube is laid out flat. And that's just exactly what I'm doing here with the rock. I'm cutting some edges on my model and unfolding it and laying it down flat. And you can see the texture map, how it's applied to the unfolded surface right here. So these white lines going around are where my seams are for this rock object. And we'll go over at a later time how to avoid these kinds of things. There's multiple different methods to fix seams, but I just want you to be aware of what goes into applying textures to a 3D modeled object that you make. You have to UV it. All right, let's go ahead and proceed with the part of the video where we are going to create our own material from scratch together. So I'm going to go back here, and we're going to make a brand new rock texture. So I'm going to create a new folder, and I'll just call this rock 1, and I'm going to take the material and the texture maps and put it inside this folder. And I'm going to create another new folder I'm going to call rock 2, and this is where we are going to create our new rock material. Create material. This will be alt rock. And while I'm at it, I might as well just go ahead and make another version of this rock that we will apply the different material to. We can do a nice side-by-side comparison. Okay, and let's give this a rotate so it just looks a little different. There we go. Perfect. All right. So I'm also going to provide you the link to this awesome resource called Polyhaven. They have a bunch of open source assets. There's HDRIs for skyboxes. There are, or I should say, sky domes. There are textures and there are models. So I will also, send you this links. But we're going to be focusing on the texture section, and we're going to make a new rock. So let's take a look at the options that they have. There's a whole section dedicated to rocks, and let's pick something that looks pretty interesting. I want to do something that has some very clear, distinct edges. Let's go with this. Let's go with this concrete rock path, I think. No. I want to pick something more interesting. Oh, here we go. Okay, we're gonna go with this rock boulder cracked material. So what I'm going to do, I'm going to stick with the 4K textures because we have the computing power to do that. You could download the Blender, or you could get the have everything downloaded into a zip. I'm just going to download the Blender. It's totally fine. Click download, and everything's going to come in a zip folder. So we're just going to let that finish, and then we'll move on. All right. So once you have your download done, you're going to get to the zip folder in your downloads folder, and you're going to extract all. However, I recommend that you take these files that you're extracting and you save them somewhere else on your computer, because when the computers get reset, all of the downloads get removed. So if you need to get back to these textures, that's something important that you'll need to be able to do. Make sure you save these to a different spot in your computer, somewhere in the C drive. Alright, so let's go ahead and extract all. I'm just going to extract it right here. And it opens it up, and I can get to my textures. So you can see, let's view this in extra large icons. Some of these images are a .exr, which is just another type of image file that is supported by 3D modeling software and Unity. So if you can't see the preview, don't worry, that's okay. Windows just can't give you a preview of a .exr file. But you can see here we have a displacement map specifically for this rock texture. Roughness, okay good, it did give us a normal. So we have a diffuse, a normal, and our roughness map, which is perfect. So we're just going to stick with these three. I'm going to highlight these, and let's bring them into this folder in Unity. There we go. Each of them has been imported. So I'm going to select our material. I'm going to go ahead and apply it to our new rock. You don't have to do this, but I just do it because I like to see the changes happen in real time for our models. So let's switch over to the Autodesk Interactive render pipeline, and let's go ahead and start applying these. So base or color map, we're going to bring right there into our color map and enable. And then for our normal map, bring that right in, enable. And as you can see, the seam in here is like very, very obvious, but I'm going to go over something as well with you all that allow you to mitigate this a little bit. So I'm just going to move around here so we can't see that seam. And let's go back to the material, and then for our roughness map, oh, okay, really quick. So I've imported this normal map, right? And you can see this texture is not marked as a normal map. I can click Fix Now, and Unity will automatically do it, which is fine, you can do that, but I just want to show you the proper, way to do this as well. So if you select the texture file in the inspector under texture type, we're going to select normal map and click apply, and that will get rid of that error for us. And you can see that the color of it changes as well, which is good. We want that because that's going to give us more bump data for our material. So now that error is gone, and I'm going to go ahead and bring this roughness map and enable. And there we go. Now we have two different rock textures using 3 texture files. So let me go ahead and rotate this around again, and there's our seam. And there's a few different things that you can do. Like if your texture file, for example, seems too large, things don't look proportionate, you can go in and change this. You can change the UV offset on the X and Y and the UV scale, and you want to make sure this is uniform. So if I want this to look like more scaled down, let's say I want this down to 0.5, I want to do this at both the X and Y, not just one or the other, because you'll end up with some strange deformations. And now you can see it's like the whole image, or all of the texture files, are larger on this. So let's go and do the inverse. Let's say I wanted everything to look smaller. Go to 5. And now you can see it has a totally different look to it because I'm repeating this texture multiple times. And now it's even harder to see that seam. It's still right there. And again, we'll go over how to mitigate this at a later time, but I don't want to bog down this video any more than it needs to be. But that includes all the basics of PBR materials in Unity. So in your scene, what I encourage you to do is go through Polyhaven, look at the different textures, find something that is interesting to you. You could go with like brick textures, you can go with rock, you can go with different metals. There's the options are endless. And you can apply these materials to different objects in your scene. There's even stuff for terrain, all sorts of interesting things. Wood. And they're all wonderfully created PBR materials that you can use in your project. So go through here, find things that are interesting, create materials, apply them to things in your scene, and see what kind of, nice kind of set dressing that you can do inside of Unity. So I know this was a longer one with a lot of information. What I want you all to make sure you take the time to do is review the guide for the different types of texture maps that I'm going to include in the module for this. It is imperative that you have a strong understanding of what each of these texture maps do. It is a extremely frequently easy to ask questions on these certification exams. It will come up multiple times. They're going to point to an image of a normal map and they're going to say like, what kind of texture map is this? They'll point to an image of a color map. What kind of texture map? With a roughness, those kinds of things. And you're expected to know just by looking at the image what kind of texture map this is. So be prepared for those kinds of questions. Take the time to fully understand it, and we will dive more into materials potentially if we have the time at a later date on a later video. So good luck, guys. Enjoy making these really cool materials and assembling your scenes, and I'll see you in the next one.